Right, in this video, we're still in section 15.1 trying to build our intuition for double integrals. And we've done a couple Riemann sum approximations. We've done the n is equal to 2, m is equal to 2 case, the n is equal to 4, m is equal to 2 case. And I just want to do one more example in terms of patterns. I'd like to take a look at the the n is equal to 4 and m is equal to 4 case. And what that's going to do is it's going to give us 16 different rectangles. We're going to have 4 divisions in the x direction, and then we'll have 4 divisions, 1, 2, 3, 4 divisions in the y direction. And we're going to do the upper right corner again. So we'll have this corner. Here are all the points where we would need to evaluate the function. Okay. And now we're going to try to be smart about this, and we're going to look for a pattern. Okay. So essentially what we need to do is to look at the function evaluated at 1, 2, the function evaluated at 2, 2, and we're just working along this first row here. 2, 2, the function evaluated at 3, 2, and then the function evaluated at 4, 2. Okay? And then the pattern continues, right? So what we can, let me see, this line here could be written as the summation I going from 1 to 4 of the function evaluated at I, comma 2, right? So that would give us this first row of function values, okay? We can then move to the next row, the function evaluated at 1, 4, plus the function evaluated at 2, 4, plus the function evaluated at 3, 4, plus the function evaluated at 4, 4. Okay? And all of that could be written as the summation I going from 1 to 4 again of the function evaluated at I, comma 4. Correct? And then that would be this row done. Okay? So what I'm wondering if we're seeing here is that this number, the y value, was also changing. It went from 2 to 4, right? It's going to then go from 2 to 4 to 6 and to 8 to get these next rows there. Okay, so my claim is that if we were going to express these 16 entries as a sum, a single sum, right? You wouldn't be able to do it. You would need one sum for each direction. The I goes in the x direction, right? And we would need another sum to count for the 2 to 4 to 6. And we will then have to introduce another sum to do this problem. Okay? So the way to combine and do all 16 of those entries as a sum, but in this case as a double sum, would be the summation I going from 1 to 4 of the function evaluated at 0 plus, right, I multiplied by delta x. And the 0 plus I delta x, we got delta x from the b minus a divided by, and we split that up into 4 pieces. So we got I times 1, which was just I. Okay. So that's what, before we were having just an I here. But now we also need to do something for the j entry, and we're going to start with 0 plus j times delta y. And delta y, we need another letter for another sum variable. summation j goes from 1, and we also split that into 4, right? And we started our endpoints where the bottom endpoints were 0, and we were doing right endpoints, so we're doing 0 plus a little bit. And that delta y was going to be 8 minus 0 divided by 4, so we were getting 2j. Okay, so if we wanted to do that Riemann sum, we would do that in notation as j going from, I'm sorry, I should keep with the color scheme going here. We would have the summation j going from 1 to 4, because we had 4 rectangles in that direction. We also had 4 rectangles in the x direction. And then we would simply want to evaluate our function at I, and then 2j. Okay, and then we would have the width of those rectangles. We would have the delta y, excuse me, delta y, delta x, and the area was going to be 1 multiplied by 2. Right? So what we're seeing here is that this is I, this 1 here is delta x, and this 2 here is delta y. Okay. So now you could see that if you wanted to take and expand this thing again, that if I went from 1 and j was 1, then the first thing you would have to add would be the function evaluated at 1, 2. And then if I stayed 1 and j continued on and went j equals 1 to 2, j went to 3, j went to 4, I would always be 1, but then j would go to 4 to 6 to 8. And that would be I always being equal to 1, and then the j would have made the 2, the 4, the 6, and the 8. And then when you get to I is equal to 2, you'd have the function evaluated at 2, and then j would go from 1 to 2 to 3 to 4 again, and you would get the 2, the 4, the 6, and the 8. And I hope you can see that we can then continue I going from 1 to 4, and we'd get the I equals 3 and I equals 4 columns. And then we would get all of the function values that we needed. So here's a really condensed notation for those, for the Riemann sum that was shown here in the picture. Okay, so that is just an introduction to the Riemann sum notation. In the next video, I'll actually do infinity rectangles, and we'll actually show how to do the math and evaluate the Riemann sum, evaluate the sums out.